So very good morning students. So today we are having our second experiment. The name of the experiment is study of characteristic of LED, that is light emitting diode. Okay. So basically the LEDs are type of semiconductor diode only. Okay. When external energy is provided to the LEDs, the electrons at the conduction band, okay, they are excited to the valence band and then it recombines with hole, and the net result in a energy that is in the form of light radiation. Okay, you could read these things that when the diode is forward biased, that in that case the LED comes to switch on case, or it switches on itself, and electron are combined with holes. The energy which I have already told, it is released in the form of light. Okay, so this effect is called electroluminescence. Okay, this is the effect which is called. Now remember, the color of the light is basically determined by the energy gap of the semiconductor. Okay, and also LEDs produces different colors. Okay, by using various materials which produce photons at different wavelength. Okay, if the wavelength is high, okay, then it would produce a type of red color or orange color or these kind of color. Okay, I think you already are knowing a VIBGUR, okay, which we have I think learned in class 6 or 7, okay, or 8. It is used, this trick is used to remember the light of rainbow. Okay, VIBGUR. Okay, VIBGUR. Okay, so since red color is having a higher wavelength, so it would need a very less threshold voltage in order to produce light. Okay, remember that while descending down the wavelength, the threshold voltage of the LED increases. I mean to say that the LEDs which are producing the light of higher wavelength, they are having very low threshold voltage. That means after giving a very little amount of voltage, they will start to glow. But the LEDs which are having very low wavelength, okay, for those LEDs we do need to provide some more voltage. Okay, this is the procedure here, that we have to make connection according to the circuit diagram. We can see here I have given DC voltage here, 1 kilo ohm resistance is there, an ammeter is joined in series, okay, with the LED, and there is a voltmeter connected in parallel with the LED. We will switch on the voltage and we will increase the voltage in a step of 0.5 volt. Okay, so if you do need to get more details in the graph, we do change this 0.5 volt increment to 0.25 volt. Okay, so now I am going to move on to the multisim part, and I will show you that what actually this circuit shows the output, how it shows the output. And just wait for a few seconds, the multisim is going to start. Okay, so this is the multisim main window. Okay, so this portion is the breadboard part. Okay, these are the menu buttons. Okay, here. So what we are going to do, we are going to create a small circuit of LED. Okay, a simple LED. So firstly I am going to take a diode. I am going to click here, diode. In the diode I will click on this LED bar. Okay, so here you can see here that many bar LEDs are present. That means many LEDs are in stocked in a single device. Okay, so we are not going to use those kind of thing. We are going to just use a single LED. So here the options for single LED are present. For iridium, orange, red, yellow, green, blue color are there. Suppose I am going to just use a red color here. Okay, Just click on this thing, OK button, put it here. Now I am going to use a resistance, so I will go to this basic portion. In basic, I am going to click on this register button. Here 1 kilo ohm is already selected, so I will click on this OK button. Okay, so now I am going to use the source, the DC source. Here the power source is here, so here the DC power I am going to choose. Now I do also need a ground also, so these things I have taken. Okay, now the voltmeter and the ammeter portion, in this thing I will just click on this multimeter, okay, here, and I will use this multimeter, one multimeter as my ammeter and one multimeter as my voltmeter. Okay, so firstly we will not connect these ammeter and voltmeter. I will show you that how actually the characteristic of the given circuit in the manual behaves. Okay, what is the characteristic, what is the graph of IV? Okay, you will see that it looks like similar as that of our silicon diode or germanium diode. So for that thing, what I am going to do, I am going to just connect these things. Here just see, I have connected the circuit. Now I am going to just click on the simulate button, and I am going to click on this analysis and simulation button. In this thing, since we are going to use DC voltage, so here the source is V1. Just see here, this V1 is the source. Okay, so voltage here in the breadboard, it is 12 volt. Okay, so we are not going to use that much voltage, so we are going to start the value from 0 volt. Just take the stop value to 4 volt and the increment value to 0.25 volt. Okay, now in the output I don't need to add a variable, IR1 is there, just add it here. Okay, now just run this thing. Just see this transfer characteristic, the lower one is the voltage one, and that means that x-axis is of the voltage one and the y-axis is of current one. Okay, so just see here, this red LED is not giving a much output or a very negligible output till 1.5 volt. After 1.5 volt it starts to conduct. Okay, so this graph will go like parabola. Okay, since I have used up to 4 volt only, so it looks like something like linear voltage. Okay, but if I will use a much higher voltage, then it would behave like a parabola. Okay, so this one is of red LED case. Okay, now what I am going to do, I am going to just close this one and I am going to show you a different LED case. Okay, since red color LED is having a very higher wavelength. Okay, so I am going to use LED of smaller wavelength, like that is blue. Okay, so this LED 2 is blue color LED. Okay, so what I am going to do, I am going to just remove this LED 1 from here and I have put it here, and now I am going to add this LED, that is our blue color LED, in this circuit. Okay, so now, okay, remember one thing, you can directly click here also. Okay, this will also give you the DC characteristic at this time. At this time it will give you the DC characteristic because since DC sweep is already chosen here, we have chosen DC sweep since first time here, so DC sweep is showing here. Okay, otherwise it will show some interactive part. Okay, so either I could go there and or I could directly click on this one. Okay, so just click on this DC sweep and just see the stop value is here 4 volt, increment is 0.25. Okay, the variable is already chosen, IR1. Just click on this run button. Just see here, for this blue LED you could see here that at nearly 2.7 or 2.8 volt, it is not giving, or it is giving very negligible amount of current, okay, or approximately 0 ampere current, okay. After 3 volt, it starts to conduct the current at a very high pace, okay, and this graph will also go like a parabola, okay. So we can see here that the LED which is having lower wavelength, it needs a higher voltage than that of the case of those LED which are having higher wavelength, okay. Just see this first DC sweep one thing, this one is of red color LED. You could see here after around at 1.5 volt, after 1.5 volt it starts to conduct, okay, and it glows. But in the case of this second DC sweep, you could see here that up to 2.7 or 2.8 volt, this LED is not glowing, and it is giving a very negligible amount, or we can say it is not giving any current, okay. After this 2.6, 2.7 or 2.8 volt, it starts to conduct and it starts to give a very good amount of light, okay. So then, since both DC sweep are the name is same here, because I haven't chosen a different name here, okay. In the design one only, I have created this LED, red LED characteristic and blue color characteristic. So just didn't confuse in this thing, okay. This one is also of design one, this one is also of design one, but this first design one is of the red one, and when I am going to click on the second one, this will show you the second part, that is of the blue color LED part, okay. So this is the basic characteristic which I wanted to show you, okay, practically. So this thing is for learning purpose, okay. Now for experiment part, what I am going to do, I am going to connect an ammeter here, okay, in this circuit, and a voltmeter also in the circuit, okay. So what I am going to do now, I am going to just delete this wire. I'm going to click this one, I'm going to click this delete button. This first multimeter, I am going to use it as my ammeter, okay, and I am going to use the second multimeter as my voltmeter. So this I will connect across the LED. So just see here, now I am going to click on this first multimeter. I am going to click on this A button, so that this multimeter would behave like an ammeter, okay. Now I am going to click on the second one, and this one V is already selected, so this will work as the voltmeter. The DC portion is also selected, so I am going to leave this part. Now I have told you in the first experiment that if you use these kind of voltage sources, then every time when you will run this circuit, okay, in this multisim virtually, what will happen, you will get the output, and every time you have to stop the simulation, and every time you have to change the voltage by manually giving it a different voltage. So what do we do here, we just change the source here, okay. We will use a DC interactive voltage source, so that we could directly change the value of voltage by using the click of a button. So I am going to just delete this source, this V1 source here, okay, and now I am going to connect this voltage source here. Just see here to this. Now the key is A, okay. So the maximum value of voltage is 10, so we will decrease it to 5 or 4 volt, whatever with the requirement, okay. The increment is here 5%, okay. So you could decrease or increase the increment, okay, it's up to you. So I will just increase it to 10%, okay. Since I am going to increase the increment as a step size of 10%, so the value of voltage will increase like 0, 0.5 volt, 1 volt, okay, like this thing. if you are going to use here 5% increment, then what will happen? The voltage side will increase by 0.25 volt. Okay, so it's up to you. You could use anything. Okay, so just leave it to 5% here. Click on this OK button. The key is A. Okay, sorry for delay. So now I'm going to run this thing. So just see here, when I have given a 0 volt voltage to this LED, here there is no current, also there is no voltage across this LED. Okay, remember this LED is of blue color. Okay, this LED one, I have changed its name. So now I'm going to increase the voltage by pressing A of keyboard. Just see here, when I have increased the voltage to 0.25 volt step size, the current here it is showing to 255 pico ampere. Okay, so that is very low, and the voltage is here 250 millivolt across the LED. Again, by increasing the voltage, just see here, the current is right now also in pico ampere. I'm going to increase the voltage again. So after 1 volt, we are seeing that the current comes in nano ampere. Okay, this thing is, current is in nano ampere only. It is around 2 nano ampere at 2 volt. Okay, so in the DC characteristic, we have seen that around after 2.6, 2.7 volt, the graph sharply increases. So I'm going to increase the voltage. Just see here, at 2.25 volt, the current comes to 6.3 nano ampere. At 2.5 volt, it increases very sharply to 103 nano ampere. Okay, and at around 2.75 volt, the current increases to 2.45 microampere. So this rise is very high. Okay, so this graph just increases like a parabola. Just see here, when I have increased the voltage to 3 volt, this multimeter, which is acting as an ammeter, it is showing 38 microampere. So you could see here the values of the current is increasing very sharply when the voltage across the LED is around 2.5 volt to 3 volt. Okay, you could increase the values moreover after this thing. Okay, so just take around 10 observations, okay, of one LED. Okay, so this one is a blue color LED. Take 10 observation of red color LED also. Take 10 observations of some other color LED like green or orange LED also. Okay, just see here, I think these things were present also here. Just I'm going to stop this simulation. Just I'm going to check here which color LEDs are present here in the LED. Yes, red, yellow, orange, radium, green, blue are present here. So you could use the green one or the orange one, it's up to you. Okay, so use at least 3 different LEDs. Okay, and you will need to get around a total of 30 observations. Okay, 10 observations of each LED in only forward bias condition. Okay, we don't need to have reverse bias condition here. Understood? So just use all those observations to form a chart. Just write the observations here. Okay, so you don't need to use this table. Okay, just use the table which you got in this Excel only. Okay, just take the screenshot of that file, okay, which is having the voltage and current, okay, in this very condition only. Okay, just make the Excel look like same as that of this table. Okay, and then make a chart there and paste it here, all the 3 different LED characteristic, okay, with the values, okay, which you got in the ammeter and voltmeter, and also the graph. Understood? And here in the result, just write in here the cut-in voltage, after which the LED starts to glow. That means after which it start to conduct very highly. Okay, conduction begins here means that it starts to glow. Okay, so I could change it here, that it starts to glow. Okay, the cut-in voltage is around that voltage, after which it starts to conduct very highly. Okay, so this one is the final part of this experiment, the second experiment. Okay, thank you for watching.